Alright, we're going to work on adding polynomials now. So you should be on page 5 of your notes, about midway down the page. It says part 2, addition of polynomials. There you go. Adding polynomials. Now there's two different methods that we're going to talk about here today. The first one we've already kind of been doing, so this one shouldn't be really a surprise to you. It's combining like terms. Okay, we remember CLT. Been talking about that for a while. Okay, that's the second step in solving equations, right? We do distributing first, and then you combine like terms. Okay, so they give us the problem 3x to the third minus 2x minus 4 plus 4x to the third minus 3x squared. I'm writing too big. Let's shrink this a little bit. There you go. So it was minus 3x squared plus 2. Okay, and it just looks like a pretty big problem. Now if you look, there's just an addition sign in between the two parentheses, so really there's nothing to do. You can't do anything inside the parentheses. There's nothing that's alike. And really adding, when you have two parentheses, just means you kind of take what's inside and you put them all together, so there's nothing to change. So what I would do first is just write these without the parentheses. Okay, so you do 3x cubed minus 2x minus 4 plus 4x cubed minus 3x squared plus 2. Okay, now combining like terms just means you find things that are alike and you combine them. So remember, when we're talking about variables, they have to be exactly alike. So the variable has to be the same variable with the exact same exponent. Okay, so if we look here, we have 3x cubed and plus 4x cubed are alike. The minus 2x, I'm going to put two lines under that so I know it's different from the last one. There's no other just x's, so that's going to be by itself. We have minus 4, so that's going to get three little lines. Now that doesn't have a variable, so over here we have another one that doesn't have a variable. We have the plus 2. And finally the only thing left is minus 3x squared. Okay, so now you just look for the lines that are alike. So we got plus 3x cubed and plus 4x cubed. So you combine those, you get 7x cubed. We got minus 2x and nothing else like it. So minus 2x. Minus 4 and plus 2, so it's going to be minus 2. And then the last one left is minus 3x squared. Now, remember, when you find out your answers, okay, we talked in the first part of this about the degrees and putting them in the right order. So go by x's and go biggest degree first. So 7x cubed, okay, that's the biggest x. Then we got minus 3x squared, minus 2x, and minus 2. Okay, that's one method, pretty simple. Okay, and then I'm going to show you a different one now. Now this one, it works the same, but it's just kind of lining it up for you a little bit better. I think it's fine, but it's just, to me, seems to be more work than anything else. So feel free to do this, though, if it helps you to understand what you need to be doing and how to make sure you're doing the right things. Okay, so we have 9m to the 5th minus 2m cubed plus 6m squared, all of that plus 5m to the 4th minus 7m squared and minus 6. Okay, now columns, that's the second way. Okay, and basically what this means is you put everything into a column that matches. Okay, so we got 9m to the 5th, okay, and there's no more m to the 5ths. Okay, so then we get, I'm going to leave a little space here, and I'm going to give minus 2m cubed, and then I'm going to do plus 6m squared. Okay, now I've got the first one written. Okay, the first problem is done. So now I'm going to take the second problem, so the 5m to the 4th, and I'm going to line it up like I would be doing little columns here. Okay, so they're all going to have their own little columns like that. Okay, and you're going to put each into their own column. So there's no m to the 5th, so 5m to the 4th, I'm going to put it in this blank column right here, almost like you're doing a regular addition problem, right? You put them on top of each other. Okay, then we have minus 7m squared, so that's going to go with the other m squareds. and then we have minus 6. Okay, and now you just go down. So 9m to the 5th, there's no others, so it's 9m to the 5th. And look, we're already in order here, right? We got 4, then m to the 4th, m to the 3rd, m squared, and so forth. So we got 5m to the 4th, that's going to be positive, so plus 5m to the 4th, minus 2m cubed. And then we got plus 6 and negative 7, so we're going to go negative. You could do negative 1 if you want, or just put negative m squared, and then minus 6. And you're done. So either method is fine. It doesn't matter which one you do. Eventually, you'll probably want to get more used to doing the combining like terms, because eventually it'll be just taking kind of a lot of room to keep rewriting it like that. So either method's fine. It's entirely up to you. There's a couple of try these. So give those 3 a shot. There's 2 on page 5 and 1 at the top of page 6. So give those a shot. Pause this and get them all done. Okay, so let's take a look at the try these. So the first one, 3x squared plus 2x minus 2 plus negative 2x squared plus 5x plus 5. And then I just went through and rewrote them without the parentheses since it's just addition. You don't have to change anything. Now I'm going to go through, I'm going to do the underlining method. So we're going to underline the x squareds are together, the x's are together, and just the constants are together. So 3x squared and negative 2x squared, that's going to be just x squared. And then we got 2x and plus 5x, well that's a bad plus 5x, so that's going to give us 7x. And you got negative 2 and positive 5 will give you positive 3. So hopefully you got that one right. Alright, let me slide this up. Okay, same thing. Wrote the problem. Since it's addition, just rewrote it without the parentheses. Now I'm going to go through and underline like terms. So I have negative 2m to the 3rd. No more m to the 3rds. So I have, there's an m squared. Here's another m squared. There's an m. And there's an m. There's a constant. There's a constant. And the last one, 5 lines there. It's kind of big. Alright, now we just combine the like ones. So I'm actually going to start with the m to the 4th because I know I want to put that first. So since it's the only one, I'm going to put m to the 4th at the beginning. Okay, and if you want to, you can kind of like cross them out as you're done. Okay, then we have m to the 3rd. So only one of those, so minus 2m to the 3rd. Now m squared, so we have a negative 5m squared and a negative 6m squared. That'll give you negative 11m squared. Then we have negative 2m and positive 7m. That's going to be positive 5m. And negative 4 and negative 10 gives you negative 14. Alright, so there's your addition of polynomials. Pretty simple. Okay, just combine like terms. That's pretty much it. If you wanted to put them in columns, you can. Oh, I just remembered we have one more problem. So maybe the last one I'll put, we'll see how that one goes. Alright, so the last one, we have some y's in the problem, so it's a little uglier, okay? But I'm just going to go ahead and underline them. I like this method better. So we're going to underline, those are like terms. We have some x, y's. We have some constants. And then we have this x squared that's all by itself. Now remember, when you put these in order, it's by the degree of the x. So we'll start negative 3x to the 4th, y to the 3rd, and the positive one, so you got negative 2 x4, y3. Then we're going to go with, okay, so those two are done. Then we're going to go with the x squared, so plus x squared. Then we got negative 5xy and 2xy, so that's going to be negative 3xy. That's a very sloppy 3x, sorry. And finally, positive 7. Alright, so there's your addition. Hopefully that makes sense. I'll do another one with subtraction in just a second.